Hello students, today we will start motional EMF. Motional EMF means electromotive force. This is a force, this is electromotive force which comes into picture by the motion of the coil. Let us see. This is a magnetic field. As symbol indicates, magnetic field is inside. It is inside towards the paper. If it is constant, then a conductor is there. This is the conductor whose length is L and it is moving with velocity V. Whenever a conductor moves with the velocity V in magnetic field, then there is current produced in this conductor. There is induced EMF produced in this conductor. So, let us explain how it happens. We have taken a conducting rod which is perpendicular to B of length L. This is very important that all are perpendicular. Magnetic field V and L, they are all mutually perpendicular. Means we can imagine this like this. This is our magnetic field, this is our velocity, and this is our length. This is the arrangement. This is our length of the conductor, this is velocity, and magnetic field is going inward. Sometimes it is coming out also, but arrangement is like this, that they all are mutually perpendicular to each other. So when B, V, L are mutually perpendicular to each other, in that case we are discussing about motional EMF. So it means when a conductor moves in magnetic field, then it becomes like battery, because there is current without any battery. So it means whenever a conductor is moving in magnetic field, then it becomes like battery, source of EMF. This EMF is called motional EMF because it arises due to motion of the conductor. So let us see what happens actually. There are two types of derivations for motional EMF. One is from Lorentz force and another is from Faraday's law of electromagnetic induction. We will discuss both because in examination numericals can be asked from anyone, derivation can be asked from anyone. So motional EMF from Lorentz force. So you remember what is Lorentz force? This is a conductor. In conductor there are free electrons, and free electrons means charge. And whenever a charged particle in magnetic field moves in a magnetic field, there is force on that charged particle, and that force is called Lorentz magnetic force, and that is force is equal to QVB sin theta. QVB sin theta. This is given by, now here charged particle, because in conductor there are free electrons, so we can replace Q by E. We are not giving sign, we are just writing magnitude because that will be given in the direction. So EV cross B means, because V and B are now perpendicular, so it is EVB. This is EVB because EV and perpendicular, so angle is 90 degree, so EVB. To find direction, use right hand palm rule. Now we want to find direction of this force. To find the direction of this force, we will apply right hand palm rule. This is going inside, and this is the velocity. So our force will be this is going inside, and this is the velocity. To find direction, use right hand palm rule. So this is direction of this one, and this is direction of this one. So this positive charge will move this side, because this right hand palm rule will give the direction of positive charge. When positive charge will go this side, electron will go downward. So electron will go downward. To each electron, downward force, positive and negative. Whenever electron there is in a downward force, then it means in conductor we will see this picture. Negative charge will accumulate here because all electrons are suffering downward force. So in a conductor, a situation like this appears. This is all electrons and this is all positive charge. So whenever negative and positive charge are separated, it means there is production of electric field. So it means there is electric field, and these charge are separated by some distance. So it means there is some potential difference, or we can say EMF. So this E is equal to QE. FE is equal to QE. So there is force, and this will be because negative charge, negative force is always opposed to the direction of the electric field. So it means whenever charge is there in electric field, it start producing force in upward direction. So there are 2 points. Whenever a conductor moves in magnetic field, then there is downward force to electron. But the same, when downward force is there, then this electron and positive charge particles are separated. So electric field is set up, and this electric field is set up, and this set up electric field will give force to the particle. This direction of this force will be opposite to electric field, because positive charge give force in the direction of electric field and negative charge is opposite to the electric field. So in nutshell, we come to the conclusion that magnetic force gives downward and electric field is upward. So with the time, a condition come when the magnitude of Fm and Fe are equal. So Fm is equal to EVB, Fe is equal to QE. So they are equal, and we get a expression E is equal to VB. This is very important. It is the relation between electric field and magnetic field and velocity of the particle. So E is equal to VB. Now whenever a charged particle is under the magnetic force and under the electric force, and they are equal and opposite, then electron will be in equilibrium, or we can say it is in steady state. And in this condition, there will be induced EMF in the conductor, and that will be given by E into length of the conductor is equal to delta V. Delta V means potential difference between the two ends, or we can say E. Now E is equal to VB. So E induced EMF is equal to E is equal to BVL. In short, we can remember like Balwant, BLV. Induced EMF is equal to BLV or BVL. So delta V is equal to EL, electric field into length, because we remember the derivation, delta V upon delta R is equal to minus E. So here we are taking just magnitude. So E is equal to BLV. V cross B will indicate the direction of positive side. Now when there is battery, so battery EMF, one side is always positive, one side is always negative. So direction of V cross B will give us the direction of positive side. Now in this case V cross B. So V is this side and B is inside. So V cross B means like this. This is V, this is B. V cross B. So it means upper side is, this is positive. So this is upper side, this is positive. Now the same derivation of motional EMF from Faraday's law of electromagnetic induction. By Faraday's law, we all know we will take the flux change. So for flux change, this is same conductor. This is same conductor. And here this is just rail type structure is imagined, and this is a conductor in which this conductor is fitted, and this conductor is moved slowly by a distance dx. This is the distance by which it is moved. So when it is moved by the distance dx, then area of this area of this will increase. When area will increase, flux will change. So let us see, in a time, flux, if it is there, then flux is BA cos 0, because here area vector and magnetic field both are parallel. So angle is 0. So BA. E is equal to d phi by dt. Phi is BA. So we get value of E is equal to d dt by BA. Let in time dt, the rod moves distance dx. Change in area of loop will be, because this is dx. So change in area will be LDX. Change in area is LDX. So when we will take d by dt of B, then B is here, L is, A is change in area, d by A dt. In value of dA by dt, we will write L dx by dt. L is outside, dx by dt is V. Again we get BLV. So induced EMF is equal to BLV. Again direction. For direction, use V cross B. V cross B means this is velocity. Again V cross B means this is V cross B. So upper side is positive, lower side is negative. Easy to find positive. For direction, Lenge's law also can be used. Now we will see for direction, because by increasing the area, flux will increase. Flux will increase. It means our already field is this side. We want to oppose it. So we want to oppose it means we will apply the induced current in such a way that field should be like this. It means it is anti-clockwise. So this is anti-clockwise. So this is direction of induced current. This is anti-clockwise means current is going from here. So it means this side is positive, current is going from here. So this side is positive and this side is negative. So in next class we will discuss different cases. Here we have discussed only when E, B and L, they are mutually perpendicular. In next class we will take general case in which it can make any angles.